Hi, good morning, everyone. And that's a lot to tell you all about Ranplan in 15 minutes. I don't know if I'll be successful at that, but I do have some slides to present this morning and discuss. Hopefully, you'll learn a little bit more about Ranplan, what we'll do, some information on how we see the market evolving, feedback we're getting from customers in the marketplace. So I have a few slides. I have a clicker, so I'm going to click my clicker. Oh, here it is. So it's on this side and this side. I have glasses on. I don't know if I need my glasses or not. So I built an agenda just to go through, and basically starting with an introduction, so a very, very brief introduction of Ranplan, who Ranplan is, what we do, and also talk a little bit about trends that we're seeing in the marketplace from our interaction with our customers, some more of the specific challenges in designing urban networks, and again, what we're seeing in the marketplace. And then the approach, which really a three-tiered approach that we look at in terms of methodology of designing to meet the challenges that are presented with designing these wireless networks. So first of all, so who is Ranplan? So we are a UK-based company. And we have an office for the Americas based in Dallas. So, and what we do is we're software developers. We focus on one thing and one thing only, and that's developing software and software solutions for wireless network planning. Any of the other products that we sell or services that we promote, they're all built around supporting and feeding the software and the users that are deploying the software. That's really our focus. And what's unique about the software, so everyone, you present yourself in the marketplace, you want to have a unique value proposition. So what is unique about the software is that, so it's used primarily for in-building design of wireless networks, which is certainly challenging. But what it does is it actually takes into account the outdoor environment in addition to the indoor environment. So if I'm designing a system in an office tower or a commercial area, I have to recognize that as part of the HETnet, I may have influence from macro sectors, from ODAS, from Wi-Fi, and they're going to penetrate the buildings and they're going to cause issues potentially with interference, et cetera. So wouldn't it be great if I can actually account for that as a planner and understand the environment with a little more granularity. If we look at sort of some broader themes, I've kind of picked three sort of broader themes to look at and what we're seeing in terms of driving the future of design for urban planning. So one is, things like safer buildings initiative and compliance. So whenever you have government compliance in any industry, it really drives economic activity. So there are a lot of people in the marketplace that will have questions about compliance. They're going to fear compliance. They're going to want to make sure that they comply because there may be financial penalties, et cetera. And as a consequence, we're seeing actually a lot of new players and a lot of interest from people providing services with respect to designing in-building systems that may not have done it before in the past. So they may, for example, have provided other infrastructure for construction of buildings and new buildings and thought, yeah, I'm seeing a lot of demand for compliance in this area. I'm going to get into this wireless network planning segment of the market to expand my business place. And beyond that, the Safer Buildings Initiative, we're really looking at, safer cities because we are expanding beyond just the environment of the in-building itself. We're talking about the campuses, the downtown cores, the whole environment. You can see on this picture here, for example, one unique property with the software is, yes, you can import a CAD design, you can do a design for the network floor by floor within the building, but then you can also geolocate the building and you can embed it into a GIS system that represents all of the other buildings, the surrounding areas, the buildings and the vegetation in 3D. And operators will use this sort of environment and data when they're designing their macro networks and ODAS, for example. So you can really merge the two together. The next item on the list, in terms of trends, coverage, capacity, expanding data requirements. So we're seeing, in discussions with customers and seeing what's happening in the marketplace, we're seeing in terms of public safety, for example, a move from focus on coverage specifically to also looking at potentially much greater expansion in capacity requirements for data usage. So scenarios where law enforcement, first responders will be streaming video in real time potentially, and that data is then used to incorporate response and to specific scenarios. So really, a move away from simply planning for coverage, but also planning for capacity. And having, again, to do that, you have to have a much more granular view of the network, specific services that are provided by the network, how those specific services will grow, and what the demand will look like, and to be able to account for that and plan for that. And then the last point on here in terms of trends is just the general complexity of the HETnet network as it expands. So again, understanding that I'm not designing for a network in isolation just for in-building, that I have colleagues that are designing the macro, the ODAS, the Wi-Fi, et cetera. And in many cases, they may actually be operating blind, really not having a good understanding of those specific in-building systems. So the ability to, it goes both ways. So designing in-building, you can account for the outdoor coming in. Designing outdoor, you can account for the impact of the in-building systems coming outdoors as well. And when we talk about 5G and higher frequencies and millimeter wave, et cetera, that's getting more challenging as well too, and there's a requirement for a higher level of granularity and visibility into what is happening in the network versus operating blindly. So, so hence, if you kind of add all of these things up, it's really driving increased demand for planning, increased granularity, and certainly an increased requirement for compliance is going to drive activity. So I think services in this area are really going to expand in the requirement. And frankly, a lot of the players that maybe have to meet compliance really need help in these areas because it's foreign to them perhaps. So next slide. Okay, so some more specific challenges, I guess. Macro coverage for many technologies, including P25, are insufficient, and we're looking at, we have a lot of carriers, customers that we've dealt with in the last number of years, and they're kind of racing to densify their network to meet coverage and capacity issues. So that's really a serious challenge for many network owners. Identifying trouble areas, where do I need to address networks? So in terms of compliance for in-building, formerly design criteria for in-building may have focused on high traffic areas. Where are the users? Are they in the atriums? Are they in the office space? Are they in the meeting rooms? But when you start talking about public safety, what happens when there's emergency? Where do people go to hide? They might not be in those high dense environments. They might be in closets. They might be in stairwells. They might be in basements. And when you're looking at the compliance, you're going to see a high level of compliance for coverage and a high percentage of the area on each floor. So again, and maybe a bit of a different change in terms of design goals when you're designing the networks. Need for rapid compliance, so time is money. And when you're designing these networks using planning tools, it can be rigorous in terms of project setup, in terms of creating the modeling environment, importing the CAD design of the building, modeling it accurately, then doing the analysis, running the radio propagation, et cetera. And again, there might be compliance deadlines that impact the customers. So that's really a key challenge in terms of delivering quickly on designs. And Finally, effective documentation and reporting. So that's always been kind of an issue. So at the end of the day, the deliverable quite often is a compliance report that says, we've done the design, here are the metrics on the design and the coverage and the capacity, et cetera. Here's trouble areas that we identified, and here we are in compliance. So being able to easily share that information and that deliverable. The approach, as I mentioned, is sort of a three-pronged approach in terms of leveraging Ranplan to walk through. So the first one is really identify. So identifying not only where you have good coverage, where you don't have issues, but also, of course, where you do have issues. This is about bringing the greater visibility into your existing designs or the starting point with your networks. Where you don't have measured data, traditionally with planning, you'll fall back to prediction. And again, prediction is only as accurate as the input data that you put into it. With a tool like Ranplan, where I don't have measurements for various reasons, there's lots of practical reasons why you may not have access to measurements to really understand what the behavior of the network is in a specific area. You want to be as accurate as possible with your prediction. So we incorporate something called 3D ray tracing model. I'm not sure in the room who's familiar or interested in propagation modeling, but when you talk about creating an environment of very accurate inputs, from propagation perspective, you're talking about ray tracing, and the inputs for them are high resolution building structures. So not just a representation, generally speaking, that, okay, this area is commercial, this area is industrial, this is residential, this is open space, et cetera, but something really, really quite accurate. And in this case, we have geolocated wireframe representations of CAD drawings of in-building systems that are embedded into in the environment. And again, it's all about setting yourself up to do the most accurate prediction or design of the network that you can, as a first cut anyways, so that you have lower cost, faster implementation, and lower cost going back and correcting changes, et cetera. Where you have measurements, you want to leverage measurements, and you incorporate that into the tool as well too, just to increase the accuracy of the models and the environment and the behavior of the network. So again, where you do have data available, you can certainly bring that in to the network, but there's lots of practical, as designers and planners, lots of practical impediments that we face in that area. So when we look at design, which is kind of the second phase, so identify, design, second phase, the first point really comes back to designing for public safety and designing for areas that may not have been traditionally accounted for. And again, it's hiding areas and making sure that you achieve compliance with total coverage area, floor by floor sort of thing. So again, addressing areas that may not have been really required or priority in the past within building. Requirements for rapid deployment of systems. So design tools, with any design tool, customers are always looking for fewer clicks. They're also looking for automation of processes within the tool. So we bring that to the table and try and leverage that and that sort of feedback, because in some cases, when you have manual processes with a design software, it can be very tedious and very time consuming. So in the interest of the market and the customer, et cetera, and speed to create design and do it accurately, you look for economies in terms of workflows. And finally, the last point, accuracy matters. So again, the more accurate the input data, the more accurate the design in the first pass, the reduced cost to the customer. And I think we're going to see really an increase in the marketplace, driven by compliance requirements, et cetera. And finally, so compliance. To have the ability to accurately and report on compliance issues, and as an engineer to do it with confidence. So to have input data that gives you that confidence in the generation of the design that you've created, incorporating and showing where you've added measurement data to it, being able to report on the metrics that are important to the customer, in terms of compliance, being able to do it in a seamless fashion, being able to produce those reports for consumption across all stakeholders. Those are sorts of feature sets that you want as well too in terms of the overall process. And that's really, you know, kind of my last slide. I guess to summarize, I guess the key points are, A, unfortunately, the future of urban wireless planning, it is complex, and it seems to be getting more complex every day. New technologies coming on board, and certainly if you partner that with the requirement for assurance of network quality, availability, capacity, and those things, you can see where the stakeholders are really going to want to assure that they can do it cost effectively. But I think it's going to be a really growing and expanding market. That's going to be challenging, but hopefully leveraging the right tools can make it easier. So that's it. Thank you very much.
All right. Thanks so much, Jeff. Jeff Gifford, everybody from Ranplan. Come on up and meet Jeff when you get an opportunity. Jeff, thank you so much. Appreciate it. And I'll even steal that one back from you.